Welcome to this session. This session, we are going to discuss about Hermitian and square Hermitian matrices. So there's a theorem which relates to any given square matrix A. It can always be expressed in the form R plus IS, where R and S are Hermitian matrices, and R is given by a half into A plus A power theta. S is given by a half into A minus A power theta. Remember, by definition, A power theta is the transpose of the conjugate of the matrix A. So let's see how we can apply this theorem to express a matrix as a sum of Hermitian and square Hermitian matrix. So the problem states express the matrix A given by 1 plus I, 2, 5 minus 5I, 2I, 2 plus I, 4 plus 2I, minus 1 plus I, minus 4, and then 7, as the sum of Hermitian matrix and skew Hermitian matrix. So this is the problem. To express the matrix A as Hermitian and skew Hermitian matrix. So we start by defining A power theta solution. So A conjugate will be given by 1 minus I, 2, 5 plus 5I, minus 2I, 2 minus I, 4 minus 2I, minus 1 minus I, minus 4, and 7. So that's the conjugate of this matrix. Simply, you get the conjugate of every element of the matrix A. This implies A conjugate transpose, which is the same as A power theta, will be, now we get the transpose of this conjugate matrix. So 1 minus I, 2, 5 plus 5I, and then 2 minus 2I, and then 2 minus I, 4 minus 2I, minus 1 minus I, minus 4, and then 7. So that is the transpose of the conjugate matrix, 1 minus I, 2, and then 5 plus 5I, minus 2I, 2 minus I, 4 minus 2I, minus 1 minus I, minus 4, and 7. Next step, let's define A plus A raised power theta. So we'll have A is given by 1 plus I, 2, 5 minus 5I. B, then next we have 2I, 2 plus I, and then 4 plus 2I, minus 1 plus I, minus 4, 7. And then we are adding to this matrix 1 minus I, minus 2I, minus 1 minus I, 2, 2 minus I minus 4, 5 plus 5I, 4 minus 2I, then 7. So when you're adding matrices, we add element twice. So this will be 1 plus I plus 1 minus I, 2 minus 2I, 5 minus 5I, minus 1 minus I, 2I plus 2, 2 plus I plus 2 minus I, 4 plus 2I minus 4, minus 1 plus I plus 5 plus 5I, minus 4 plus 4 minus 2I, 7 plus 7. So simply add corresponding elements. Now that sum will be 1 plus 1 is 2, I minus I is 0. So this will be 2. And then 2 minus 2I. 5 minus 1 is 4. Minus 5 minus 5I minus I is minus 6I. This will be 2 plus 2I. I minus I is 0. 2 plus 2, 4. 4 minus 4, 0. So this will be 2I. And then minus 1 plus 5 is 4. I plus 5I is 6I. And then minus 4 plus 4, 0. So this minus 2I. And then this is 14. Then R is given by a half into A half for 2I, 4 plus 6I, minus 2I, 14. And then a half of every element will have 1, 1 minus I, 2 minus 3I, 1 plus I, 2 I, 2 plus 3I, minus I, this will be 7. So that would be our R matrix. And this is actually the summation, because all the elements along the main diagonal are real numbers, and conjugate elements are conjugate of each other. So next, let's define A minus A power theta. This will be A matrix is 1 plus I, 2, 5 minus 5I, and then we have 2I, then 2 plus I, 4 plus 2I, this is minus 1 plus I, minus 4, 7. Then we subtract. A power theta was 1 minus I, minus 2I, minus 1 minus I, 2, 2 minus I, minus 4, 5 plus 5I, 4 minus 2I, 7. So let's subtract, and just remember subtraction is termwise or component-wise. So A minus A power theta is 1 plus I minus 1 minus I, 2 minus 2I, 5 minus 5I, minus 1 minus I, and then we have 2I minus 2, and then 2 plus I minus 2 minus I, 4 plus 2I minus 4, minus 1 minus plus I minus 5 minus plus 5I minus 4 minus 4 minus 2I, 7 minus 7. So A minus A power theta will be now 1 plus I minus 1 plus I, 2 plus 2I, 5 minus 5I plus 1 plus I, and then 2I minus 2, 2 plus I minus 2 plus I, 4 plus 2I minus is plus, and then here we have minus 1 plus I minus 5 minus 5I minus 4 plus 2I, 4 plus 2I minus is plus 4. So A minus A power theta is 1 minus 1 is 0I plus I is 2I. This will be 2 plus 2I. 5 plus 1 is 6 minus 5I. This would be minus 4I. And then this is minus 2 plus 2I. And then this I plus I is 2I, because 2 minus 2 cancels out. This will be 8 plus 2I, negative 1, negative 5, negative 6, and then minus 4I, minus 8 plus 2I. This will be 8 plus. So here we had this element. Now this was supposed to be 7 minus 7, which is 0. So that's this misplaced value here. From here, this 7 minus 7, which is 0. So this is 0. This is 0. So this means S, which is given by a half, into A minus A power theta is a half of this matrix 2I, 2 plus 2I, 6 minus 4I, minus 2 plus 2I, 2I, 8 plus 2I, minus 6 minus 4I, minus 8 plus 2I, 0. Now multiply half by every element. S, which is a half, into A minus A is given by, that will be I, 1 plus I, 3 minus 2I, minus 1 plus I, 4 plus I minus 3 minus 2I minus 4 plus I, and this will be 0. You can see that this is skew symmetric. So then, if I say R plus S, I'll have R matrix was given by 1 minus I, 2 minus 3I, 1 plus I, 2I, 2 plus 3I, minus I, 7, and then plus I plus 1 plus I, 3 minus 2I, minus 1 plus I, 4 plus I, minus 3 minus 2I, minus 4 plus I, 0. So if we are to get this sum, now 1 plus I is 1 plus I. This plus this, so be 2 cos minus I plus I is 0. This plus this will be 5 minus 5I. This plus this, 1 minus 1, 0. So this will be I plus I, 2I. So remember this was here 1 plus I minus 1 plus, so this will be 2I, correct? And then 2 plus this will be 2 plus I plus this will be 4 plus 2I, and then this plus this minus 1, and then plus I, and then this would be minus 4, and this 7 plus 0 is 7. And you see this was the matrix A that was given. So therefore, A has been expressed in terms of a symmetric Hermitian matrix. So remember, this is Hermitian, and this is skew Hermitian, and that was the objective. So this plus this gives us our A matrix. Thank you.